Back in 1799, a guy named George Shaw at the British Museum got a package that he was convinced was a total prank. It looked so fake that he actually took scissors to the bill, trying to find the stitches where some taxidermist must have sewn a duck's face onto a beaver's body. But there weren't any stitches. He hadn't found a hoax at all. He'd actually stumbled onto an 180 million year old error message from evolution. It's a creature with the genes of a reptile, the sensors of a shark, and the nursing habits of a mammal. Today, we're going to find out how that's even possible. The thing is, the platypus didn't fail at being a mammal. It just found a way to win in a world that hasn't really changed much since the Jurassic. To understand this little guy, you've got to look at a huge fork in the road. Around 166 to 180 million years ago, the mammal family tree split in two. One group, the Therians, went the route of the placenta and live birth. That's us. We chose a high-energy, fast-moving path that required some pretty massive biological upgrades. The other group, the monotremes, stayed basal. They kept laying eggs, kept their old-school reptilian shoulder bones, and even kept the cloaca. Yep, one single opening for everything. To us, that might look primitive. But in the world of biology, primitive doesn't mean it's bad. It just means it hasn't changed. And honestly, you don't stay the same for 180 million years, unless you're already doing everything right. While our ancestors were busy evolving big brains and social lives just to survive a crazy world, the platypus was busy perfecting a toolkit so good it didn't need to change. In 2021, scientists finally mapped out its entire genome, and it confirmed what we've always suspected. The platypus isn't some glitch. It's a total masterpiece of engineering. We're looking at a biological third way that beat the game of survival long before we even showed up to play. Let's start with the most famous part, that bill. Most people think it's hard like a bird's beak, but it's actually soft, rubbery skin. And it's packed with something wild, 40,000 electroreceptors and 60,000 mechanoreceptors. This makes the platypus one of the only mammals on the planet with a legitimate sixth sense. To see why this is so cool, we have to look at the physics of how they hunt. In the muddy, messy rivers of Australia, you can't see a thing. So, when a platypus dives, it just shuts its eyes, ears, and nostrils. It's basically blind and deaf down there. Yet, it can still snag a tiny shrimp in total darkness with the precision of a laser. How? Well, the bill works like a biological oscilloscope. See? Every time a living thing moves a muscle, it lets out a tiny electrical spark. In water, that spark travels almost at the speed of light. But that same movement also sends out a physical pressure wave, a thump, which is much slower, traveling at about 1,500 meters per second. The platypus catches both. It feels the thump and hears the spark at the same time. Then, its brain does some quick math called time difference of arrival, TDOA. By measuring the tiny millisecond delay between that lightning-fast spark and the slower-moving thump, it figures out exactly where the prey is, how fast it's going, and which way it's headed. It's literally using the spark to predict exactly where the thump is going to be. And it gets even crazier. These sensors aren't just scattered randomly. They're lined up in specific stripes along the bill. This lets the platypus perform a kind of directional triangulation. If a sensor on the left side gets hit a microsecond before the right, the platypus knows exactly which way to swing its head. It's not just feeling around. It's building a real-time, 3D, high-fidelity map of electrical fields in its mind. While we struggle to build sonar that can filter out background noise in a messy river, the platypus does it with a brain the size of a walnut. It's a living computer hunting by reading the electricity of life itself. So, if the bill is high-tech, the body is definitely vintage. When you see a platypus walk on land, it looks a bit like a mistake. It kind of sprawls out. That's because it still has an epicoracoid bone and an interclavicle, bones that reptiles like crocodiles have, but every other mammal lost over 100 million years ago. Most mammals have shoulders that move up and down, which is great for running. Think of a dog or a horse. Their legs are right under them to fight gravity. But the platypus? It's locked in that lizard sprawl. Walking on land is actually a huge workout for them. It takes twice the energy it does to swim. It's like trying to do a push-up with every single step you take. So, why hasn't it evolved past this? Well, because it's not built for the land, it's built for the water. Check out its bone density. Most mammals have hollow bones to stay light and fast, but platypus bones are solid and super heavy. Scientists call this Pachyostosis. This makes them neutrally buoyant. It's like a high-end nuclear submarine. The platypus doesn't have to fight to stay underwater. It doesn't float back up like a cork. It just sinks perfectly into its world. It's basically hacked its own weight to become a low-drag, high-efficiency torpedo. That clumsy sprawl on land is actually what gives it the perfect leverage to paddle through the water with maximum power. It even has to fold its swimming webbing back and walk on its knuckles on land just to keep its flippers from getting torn up. It's a dual-purpose design that puts swimming first, and it's so good at it that it hasn't needed a skeletal update in millions of years. Most mammals use teeth or claws to fight, but the platypus uses chemistry. Only the males have these sharp, hollow spurs on their back legs that are hooked up to venom glands. But here's the weird part. This venom didn't come from saliva like it does in snakes. It actually came from their immune system. It turns out that molecules called defensins, which usually just fight off germs, got copied over and over in the platypus genome and turned into toxins. The result is a chemical mix designed to cause something called hyperalgesia. Basically, it doesn't just cause pain, it turns the volume way up on every sensation. People who've been stung say it feels like their blood turned into acid, and the sensitivity is so intense that even a light breeze on your skin feels like a red-hot iron. This pain can last for weeks, and morphine doesn't even help because the venom hits the nerves directly, skipping the brain's normal pain relievers. But there's a silver lining here that might actually help us. Inside that venom is a hormone called GLP-1, glucagon-like peptide 1. In us humans, GLP-1 helps manage blood sugar, but our version disappears in minutes. In the platypus, though, it's evolved to be incredibly tough and stable, so it can work as a weapon. Scientists are now studying this stable glitch to see if it could help create better treatments for type 2 diabetes. It's pretty wild to think that the same thing they use to pick fights in the river might actually help us regulate our metabolism. It's one of the only times we've seen an immune system, a metabolic hormone, and a weapon all wrapped into one incredible package. When it comes to genetics, humans are pretty simple. You've got X and Y. That's it. But the platypus? It has a combination lock of 10 sex chromosomes, 5 X's and 5 Y's. For this to work, they have to form a literal physical ring, a meiotic chain, during cell division. It's a level of genetic chaos that really shouldn't work according to our textbooks. And honestly, the structure looks more like a chicken's DNA than a human's. This anarchy is what allows for what I call the double lunch. Most animals choose a side, eggs or milk. The platypus says, why not both? Inside the egg, the baby feeds on yolk from vitellogenin genes that we humans lost millions of years ago, but the platypus kept. But once it hatches, it switches over to milk produced by casein genes. The platypus is the only animal on the planet that gives its kids a bird's lunch and a mammal's lunch. And get this, the mother has no nipples. There's no centralized delivery system here. Instead, she just sweats milk out of her skin through specialized pores, and the babies lap it up directly from her fur. It really makes you rethink what it means to be a mammal. We usually define mammals by giving birth to live young, but the platypus shows us that being a mammal is more about the chemistry of the milk and the genes behind it than the way you're born. It's still standing on that evolutionary bridge between reptiles and us, and it seems perfectly happy right there. And if the electricity, the heavy bones, and the weaponized immune system weren't enough, we found one more glitch recently. In 2020, some researchers turned on a UV light and realized that the platypus actually glows. Its fur is biofluorescent, so it takes in UV light and spits it back out as a ghostly neon green color. We've been studying them for 2 centuries, and we didn't notice this until just a few years ago. Why would a blind hunter need to glow? We're still guessing. Maybe it's a way to talk to other platypuses in the dim light of dawn and dusk. Or maybe it's a weird type of camouflage against predators that see in different wavelengths. It might even be a leftover trait from the Triassic period that just never went away. It's just another neon sign reminding us that there's still so much we don't know about the natural world. So, did the platypus break the rules of evolution? Not really. It just showed us that our rules were mostly just guesses based on our own history. The platypus lives in an Umwelt, a perceptual world that we can barely imagine. It doesn't see a river the way we do. It experiences a world of voltages, vibrations, and glowing spectral colors. It outlived the dinosaurs, watched our ancestors change into thousands of different species, and it just stayed exactly the way it was. Not because it couldn't change, but because it didn't need to. It's a 180 million-year-old success story, reminding us that primitive is just a word we use when we haven't figured something out yet. It's not an evolutionary dead end. It's an evolutionary masterpiece that's still teaching us what life is capable of. So, what do you think is the weirdest part? The 10 sex chromosomes, the double lunch, or the glowing fur? Let me know in the comments. And as always, keep questioning what you think you know. Subscribe for more weird and interesting facts about animals.